In this video, we're going to be covering how you can solve quadratic equations using the quadratic formula. Let's jump right in. Alright, let's start things off by just reminding ourselves what quadratic equations look like. Quadratic equations are in the form ax squared plus bx plus c equals 0. And when we say we want to solve a quadratic equation, what we're looking for are the x values that satisfy the equation. So what the quadratic formula says is that the solutions of a given quadratic equation, that is, the x values that make the left-hand side of this equation equal to 0, can be found using the following formula: minus b plus or minus the square root of b squared minus 4ac all over 2a, where a, b, and c in this formula come from the general form of a quadratic equation. Now, the next thing I want to explain is the significance of this plus or minus, and all that really is a shortcut for saying we have two solutions. The first of which is negative b plus the square root of b squared minus 4ac all over 2a, and the second of which is negative b minus the square root of b squared minus 4ac all over 2a. Now, it seems as though the quadratic formula will always produce two different solutions, one with the plus and one with the minus. But that's not always the case, and to explain this, let's consider the term inside the square root, the b squared minus 4ac. Now, this term is given a special name. It's called the discriminant, and it decides the number of distinct solutions we get as well as the type of solutions we get. Notice that if b squared minus 4ac is positive, that is, if it's greater than 0, then we have two real solutions, because these two cases will produce different results. But if b squared minus 4ac is equal to 0, then we only have one real solution. And the reasoning behind that is the following. If the square root of b squared minus 4ac is equal to 0, then for your solutions to your quadratic equation, you have minus b plus or minus the square root of 0 over 2a. And whether you add or subtract 0 doesn't make a difference. So you end up with only one unique solution. Now, the final case we have to consider is when b squared minus 4ac is negative. That is, when it is less than 0. In this case, you have 0 real solutions, because if b squared minus 4ac is negative, then you'll be taking the square root of a negative number. The square roots of negative numbers are imaginary, and so ultimately you'll end up having 0 real solutions, but 2 complex solutions. I'll make a video covering imaginary and complex numbers in the future, so be on the lookout for that. Now, before we move on to doing some practice problems with the quadratic formula, let's think about what these three cases mean graphically. So in this first case, where the discriminant is positive, our graph will look something like this. The parabola will intersect the x-axis at two different points, because when the discriminant is greater than 0, we have two real solutions. And that means there are two x values where the function, or in this case the y value, is equal to 0. So two places where the graph intersects the x-axis. Now, in the case where the discriminant is equal to 0, here's what we have. There will only be one point at which the graph touches the x-axis, and that's because we only have one real solution, which means there's only one x value that makes the function equal to 0. Now, in the final case, where the discriminant is negative, the graph could look something like this. The graph doesn't intersect the x-axis whatsoever, and this is because when the discriminant is negative, we have 0 real solutions, which means there are 0 x values in the real coordinate space that make the function equal to 0. Now, with that intro out of the way, let's do one example for each of these cases. Alright, so here we have the first problem. We want to solve the quadratic equation 3x squared plus 5x minus 2 is equal to 0 using the quadratic formula. Now, the way I usually like to start these problems is by identifying the values of a, b, and c. Remember that the general form for a quadratic equation is ax squared plus bx plus c is equal to 0. And so, as you can see, a is the coefficient of the x squared term, which in this case is 3. B is the coefficient of the x term, which in this case is 5. And c is the constant term, which for this equation is negative 2. And now that we have the values for a, b, and c, we can plug them into the quadratic equation to get our solutions. So we have x is equal to negative b, which in this case is negative 5, plus or minus the square root of b squared, so 5 squared, minus 4 times a, which is 3, times c, which is negative 2, all over 2 times a, so 2 times 3. Now let's start off by simplifying the numerator a little bit. We have negative 5 plus or minus the square root of 5 squared, which is 25, minus 4 times 3, which is 12, times negative 2, which is negative 24, divided by 2 times 3, which is 6. So we have negative 5 plus or minus the square root of 25 minus negative 24, which is 25 plus 24, which is 49, divided by 6. The square root of 49 is 7, so we have negative 5 plus or minus 7 over 6. Now let's split this up into the two different solutions. The first solution is negative 5 plus 7 divided by 6, which is 2 divided by 6, which is 1/3. And the second solution is negative 5 minus 7 divided by 6, which is negative 12 divided by 6, which is negative 2. And so the solutions to this quadratic equation are x is equal to 1/3 and x is equal to negative 2. And it makes sense that we have two real solutions because the discriminant, which in this case was 49, is positive. And if you want to think of what this looks like graphically, if you were to graph the function 3x squared plus 5x minus 2, then the curve would intersect the x-axis at x is equal to 1/3 and x is equal to negative 2, because those are the x values where the function is equal to 0. And so ultimately, the parabola would look something like this. It would open upward because a is positive and pass through the x-axis at x is equal to negative 2 and 1/3. Alright, so that was the first example. Now let's move on to the second one. Alright, so here is the second example. We want to solve the quadratic equation negative 8x squared minus 6x is equal to 2x plus 2 using the quadratic formula. And you might notice that this equation is not in the form we're used to. The general form for a quadratic equation is ax squared plus bx plus c equals 0. So before we apply the quadratic formula to this equation, let's convert it into this form. And the way we're going to do that is by bringing all of the terms onto the left-hand side. So we can start off by subtracting 2x from both sides. We get minus 8x squared minus 6x minus 2x, so minus 8x, is equal to 2. Now if we subtract 2 from both sides, we get negative 8x squared minus 8x minus 2 equals 0. And so now our equation is in the form ax squared plus bx plus c equals 0, where a, which is the coefficient of the x squared term, is negative 8, and b, which is the coefficient of the x term, is negative 8 as well, and c, which is the constant term, is negative 2. Now that we have our values for a, b, and c, we can plug them into the quadratic formula to get our solutions. So we have x is equal to negative b, which in this case is negative 8, plus or minus of b squared, so negative 8 squared in this case, minus 4 times a, which is negative 8, times c, which is negative 2, divided by 2 times a, so 2 times negative 8. Now if we start simplifying this, negative of negative 8 is just 8 plus or minus the square root of negative 8 squared, which is 64, minus 4 times negative 8, which is negative 32, times negative 2, which is also 64, divided by 2 times negative 8, which is negative 16. And so ultimately what we have is 8 plus or minus the square root of 64 minus 64, which is 0, divided by negative 16. As you can see, in this case, our determinant is 0, which means we only have one real solution, and that one solution is 8 over negative 16, which is negative 1/2. And so the solution to this quadratic equation is x is equal to negative 1/2. Now, if you were to graph this function, the function y is equal to negative 8x squared minus 8x minus 2, then you would see that the curve only intersects the x-axis when x is equal to negative 1/2, since negative 1/2 is the only x value that makes this function equal to 0. Now, since a is negative, it's negative 8, this parabola will open downward, and so ultimately the curve will look something like this. The parabola opens downward and touches and bounces off the x-axis where x is equal to negative 1/2. So that was it for this example. Now let's move on to our third and final example. Alright, so here's our final example. We want to solve the quadratic equation x squared minus 2x plus 2 equals 0 using the quadratic formula. Now this equation is already given to us in the form ax squared plus bx plus c equals 0, so we don't have to manipulate it in any way. So let's start off the same way we did the last two problems. Let's identify the values of a, b, and c. A is the coefficient of the x squared term, so it's 1. B is the coefficient of the x term, so in this case that's negative 2. And c is the constant term, which for this example is 2. Now that we have a, b, and c, let's plug in the values to the quadratic formula to get our solutions. So we have x is equal to negative b, so negative of negative 2 in this case, plus or minus the square root of b squared, so negative 2 squared, minus 4 times a, which is 1, times c, which is 2. And we divide all of this by 2 times a, so in this case, 2 times 1. Negative of a negative 2 is just 2, so we have 2 plus or minus the square root of negative 2 whole squared, which is 4, minus 4 times 1, which is 4, times 2, which is 8, so minus 8, divided by 2 times 1, which is 1. So if we simplify this one step further, we get 2 plus or minus the square root of 4 minus 8, which is negative 4, divided by 2. Now if we continue the simplification process, we get that x is equal to 2 plus or minus the square root of negative 4, which we can split up into the square root of 4 and the square root of negative 1, divided by 2. And at this point, you might be wondering, well, what is the square root of negative 1? Well, in math, we call this quantity the square root of negative 1, I. So what we have is 2 plus or minus the square root of 4, which is 2, times I, divided by 2. And now we can factor out a 2 from the numerator and the denominator and cancel. So what we end up with as our solutions are 1 plus or minus I, both of which are complex numbers. So the solutions to this quadratic equation are x is equal to 1 plus I and x is equal to 1 minus I. And it makes sense that we ended up with 2 complex solutions and 0 real solutions because our discriminant was negative, negative 4. Now, if you were to graph this function, that is the function y is equal to x squared minus 2x plus 2, then you'll get a curve that looks something like this. The curve won't intersect the x-axis at all because there are no real x values for which the function is equal to 0. Alright, that's all there is to this video. If it did help you out, please be sure to leave a like, and if you want to be notified when I post the rest of the videos on this course, make sure to subscribe. Thanks for watching.